Cool. All right, is this thing on? Oh, it is. Excellent. Good morning. Wow, a response. That's novel. So, who here likes JavaScript? And you're not next door? Thank you. If you don't know why you should be next door, then Google Node and stop playing with it, and you'll like JavaScript even more. I was going to do a demo in Node, except for I decided that the guys who liked such things would be next door, and after the arguments last night about JavaScript, thought I might make some enemies. So, I'm here to talk about RavenDB. And this will actually be a proper talk about RavenDB as opposed to Wednesday's talk where I just skipped some stuff. So, who here uses RavenDB? Wow, I actually got a hand, that's pretty good. Who here knows what a document database is? Oh hey, that's fantastic. And who here has used a document database of any sort? Okay, fair enough then. Normally at that point, I'd ask put your hands down if you use Mongo, but no one had their hands up, so never mind. So, a document database. I will recap on what one is, so I don't launch off into deep stuff about Raven and lose people. Document database stores things as documents, obviously. In this particular instance, our documents are big JSON blobs. RavenDB itself is written entirely in C#, and it's dual licensed. It's paid for closed source stuff and AGPL for open source stuff, and it uses lots of link. Who here likes link? Good. But I did another talk, and no one put their hands up, which meant the rest of the talk was very difficult, because nobody knew what the hell I was doing. So, this is a document. The only important thing about this document is, well, everything about it. It's got an ID. Every single document has an ID. That is the only thing Raven will put in your document for you if you don't supply it. And as you can see, it's prefixed with lots of underscores, which means you know it's special. Anything with underscores in is special, automatically. That's how the world works. It's got some properties, and it's got a collection on it too. So there we go. We actually flatten our structure with a one-to-many relationship there. Well, not actually one-to-many, but whatever. And we store on the document itself. When we're doing RavenDB, and I say this, and then I'll go into actually argue with myself later, we don't query documents. So in a relational database, when you do your queries, you query your tables. So the same data you put in is the same data you get out. It's not that way in RavenDB. We don't query documents. We query these magical things called indexes. So, in case there's any confusion over that, this is how it looks. Well, kind of. You have your documents, and those documents are those lovely blobs you just saw. And we copy bits of those documents into these things called indexes. And they're stored in Lucene. Who here knows what Lucene is? I was getting very tired towards the end of the session. I'm going to keep doing this. Make sure you're all awake. So, those not in the know, Lucene is a full-text indexing engine, which means you put stuff from there in there, you can search it really easily, pull things out. So there we've got an index called blogs by title, and in that we store just a title, which means we can query by title. What's that look like? Well, here's our first link of the day. How do we define an index? We write a link query to pull a projection from the document. So in this particular instance, we're saying, look at all the documents, pull out title and category. We don't care what kind of document it is, we don't care what structure it's got, just pull out these two properties. So, that's not, there we go, wonderful. So, given this document, and I'm afraid I'm expressing a document as a table here because I couldn't actually fit everything on the slide if I didn't. Each document has an ID and some properties. In this particular case, it's title, user ID, category, and description. If we define an index that looks like this, so from doc and docs, select title, we will end up with an index that looks like this. And this is all there is to indexing in RavenDB. Every single index is some kind of link query which pulls data from one place and puts it in another, so you can query it. As you can see, Raven automatically actually adds the ID to the index, regardless of whether you do it or not. And this is because the way it works is, when you do your search, you do your paging and sorting and limiting, you'll get a list of IDs, and Raven will use those IDs to pull the actual documents from the document store and return them to you, in its simplest form. This is what a query looks like. Now, those familiar with Lucene will look at that and go, hey, it's a Lucene query. And that's because it is. So if you've used Lucene in the past, Raven ends up becoming a very useful tool just for using Lucene, plus some more stuff. If you haven't used Lucene, well, it's all right, because there's lots of documentation for Lucene, which is quite nice because it means the RavenDB team hasn't got to write themselves. The entire querying language is already defined somewhere else. So it's quite simple here. I'm just saying, hey, search me for a document where the title is hello. And also, search me for a document where the title is hello and the category is Raven. So, one of the interesting properties about document database is that we flatten our structure into a single document, sometimes. So in that first example where I showed a collection of tags, that was stored in one document. So here is pretty much an example, looks like that. I have 2 documents, each with 3 tags, commented to the list, because again, I couldn't actually fit on a slide if I didn't do it any other way. To define an index, I can do this. I select many. So, if anyone's awake, how many index entries will get created from this query? 2? No. You can keep going up. The answer is 6. And I'll show you why. So we do a select many, and for every document and every tag, we create an index entry. So here we have 6. We have 3 for the first, because it's got 3 tags, and 3 for the second, because it's got 3 tags. And this is an important concept. When I do a search in Lucene for hello, I'll actually get 3 results. I just discard the duplicates. It's quite fast. It's all right. But Raven does that for you. It's quite elegant. I like it. But the queries look the same. And this is because, just like before, what we're doing is we are querying the indexes, not the documents. So in this particular case, I'm selecting the title of the document and the name of the tag. Which means in the index, we get, well, 3 properties. The ID, obviously, title, and name. When we query it, we query the name, which means find me a document which has a tag of Raven. Or here, find me a document which has a title of Raven and a tag called greeting. Querying flattened structures. So, this is where I start to get scary. Or everyone thinks anyway. If I'm not already scary. But look a mess this morning. MapReduce. Very words strike fear into the heart of man's soul. Who here knows what MapReduce is? Good. Who here is scared by MapReduce? Oh, okay, fair enough. I know we got a lot more hands, but I think you guys are a lot brighter than anyone else I ever spoke to. Or just very quiet. So here's an aggregation written by me in SQL. It's probably really bad, actually. I'm probably doing something wrong. I'm always doing something wrong when I'm writing SQL. I'm always told I'm doing something bad. That's the problem with SQL. Who understands this? In fact, who does not understand this? I've got to explain what SQL's doing here. Just a group by. I'm doing an aggregation on category and finding how many there are. Well, this is what an aggregation looks like in LINQ. There's a group by. From all the documents I've got, please group them by category into this other collection. And in that collection, store the key that I've grouped by and the number of items that I've got there, or some other aggregation function. MapReduce is simply a case of splitting this up. So, in this particular case, we do a map. You'll recognize the map because I've done these before already. Every single index is a map. You're mapping from a document into an index, which allows you to query that index. MapReduce is just doing an extra operation on that, where we say, hey, we've mapped our data into this index, now do an aggregation on that. The only interesting property we've got here is that the output of the map is the same as the output of the reduce. And there's this property that allows us to basically parallelize this if we so choose. It turns out there's actually very little point in doing so unless you've got a lot of documents. But it means you can if you want to. So is everyone following this? Yes? MapReduce. We're cool with that. Wonderful. So let's run through a very quick example to make sure we're all au fait with this. Here's some documents. Well, they're not very exciting documents. They have no properties apart from category. I thought I'd keep things simple. You'll notice 2 of these have a category of Raven and 1 has a category of SQL. To find a map statement, I'm going to group by category. And what I do is I say, okay, I'll map from my documents and I'll take the category from the document and I'll assign it a count of 1. Because I've got 1 in my index entry. And this will give me a set of index entries that look like this. So the map isn't doing any aggregation. We just say, hey, for every document, give us some index entries. If we're doing collections, it'd be the same. We'd have, from 2 documents, 6 entries. We'll aggregate them later. So Raven 1, SQL 1, Raven 1. The reduce is just a group by on that. So given this input to find the reduce, which is just a group by, everyone can follow group bys, give me the category and count how many there are. Hence, giving us an output looks like this. Now, why is this important? I'm creating indexes here to do these queries and group bys and things like that. Why am I doing that? What possible help will that give me? The help it gives me is that these are pre-calculated. So when I do a query on RavenDB, I'm doing a query on a pre-calculated view. It's a materialized view, effectively. RavenDB's model, and this is different to other document databases. This is one of the things about NoSQL. Everything's different. We're writing data, we're storing it, we're reading data, we're just doing all this stuff over here. Quite happily, the application's doing this. And it's completely decoupled from the process of actually going through the documents and putting them into a structure for querying. It's completely isolated. Happens entirely in the background. Couch, by the way, does it when you query, and Mongo just doesn't. Just queries. This is quite nice. Ignore them. Yeah, demo's next. This is quite nice because all my writes are fast and all my queries are fast. Really fast. Who here reads Ayande's blog? Okay, cool. So you noticed he upgraded lately. It's wrote a blog engine, Raven. And his blog suddenly became really fast and he could drop a server. Because he's never waiting for anything. He's just doing queries against this data. There's nothing there. And that's nice. Completely coupled. Now obviously, if I sat here and did PowerPoint all session, you'd probably get a bit miserable with me. So let's do some super awesome client demos and show you what it's all about. Look at RavenDB. First off, I'll just show you how you install it. I downloaded this 20 minutes ago. This came in a zip, looks like this. To install it, I unzip it. And I run the server, which is this thing here. Right, it's now done. Installed. It's wonderful. That was easy. Sorry? No. Is Lucene included? Yeah, Lucene. Sorry, I was going to say, yeah, Lucene. So does it include Lucene? Yes, it does. It includes everything it needs to run. Because the principle behind RavenDB is it should be easy to use from the get-go. Just like that. Let's have a quick look at it. What's it given us? It's created a data folder over here. We can pop into that, it's just a folder. Where we have some index definitions, which we'll go into in a bit. We have the indexes themselves, which is the data we've actually flattened out somewhere. Some logs, obviously. And the actual data. So on the hard disk, actually, they're split out. You have your data, and you have your indexes. Very separate. What's this look like? Well, let's find out. Ooh, Silverlight. Whoa. Those JavaScript people are probably quite offended right now. It's probably a good thing they're next door. It's beautiful, actually. I love this. It's absolutely gorgeous. It really is. Obviously, there's no data in there currently. So let's go and sort that out, shall we? I have a set of tests. I like having a set of tests because it means I can run them each time I do this demo and make sure they're working. Quickly, let's just look at my model. I say model in elusive terms. Here's a user. It's got some data on it. Here's a to-do list. Those on Wednesday will realize I like my to-do lists. I use Notepad normally, but right now I'm doing in Raven. I don't store the user on my to-do list. I just store an ID. There's no relationship there. RavenDB knows nothing about relationships. I can store strings, I can store date times, I can store anything I want to. Interestingly here, I'm storing a list of to-do items. These will be stored on the document itself. And it's a to-do item. What's interesting about this solution is, look, no mapping. I don't need to map. I've got some documents. Go into that in a second. First off, now I've installed RavenDB, which took a long time. How do I connect to it? How do I actually use RavenDB? We've actually got 3 options. I like 3 options. You can connect to the HTTP server. Looks like that. And let's talk about this very briefly. To connect to RavenDB, you create a store. This is an expensive operation, relatively. You do it in an application startup, probably. And then for every unit of work that you undergo, you create a session from that. Who here uses Hibernate? So we're familiar with this concept, right? Session factory, session. Document store, session. Same thing. It actually works very much in the same way, as you'll see. You could run that, but it's very little point. You can also run it in process. So rather than going through that lengthy procedure of installing RavenDB, you can just add a reference to the embeddable client and run it. And say, hey, just store your data here. Thank you. Very pleased with this. Let's run that. Oh, failed tests, look at that. It's all right, they're meant to fail. Promise. I'm just going to look at that very quickly. And how you work on these very small screens. So if I go to my bin folder over here, got a data directory. Without installing anything, I add some reference and I can use it. That's quite nice. And then if I want to do testing, you know what? Do the same thing. Only this time just specify I want to run in memory. Don't store anything, just work. What this means is I can actually have some half-decent end-to-end testing with data persistence and everything else without any fuss, because everything takes an iDocument store or an iDocument session, and whatever's behind that, it's all the same. Obviously, in production, you'd probably actually install a RavenDB instance and connect to it. In testing, you'd probably use a local one, flush it each time. And in unit testing, integration testing, whatever you want to call it, just do it in memory. Really fast. Like, test suite for RavenDB has like 900 tests in or something like that. And it's on an SSD, it just flies. So how do we persist our data? Well, let's look at this. We create a session. Got a base test helping me out here a little bit. I create my little Poco with some data on it. Don't spam me, by the way. But do send me money. What's interesting here is that I haven't specified the ID, and it hasn't got an ID. When I call store, here, hey, store my document, it gets given an ID. No remote call at this point is made. RavenDB doesn't like chatting. It's quite antisocial. Doesn't know about relationships, doesn't talk to people. Whew, dry audience. So nothing's been sent to the server at this point. When I call save changes, everything gets flushed to the server in one big bulk operation. So I could do this 5 times, 6 times, 7 times, do some modifications, hit save changes, everything gets flushed. And either all happens or none of it happens. RavenDB is transactional. We'll talk about that a little bit, maybe. So I run this. If I'm really lucky, it'll work. Look at that, fantastic. Let's go here again. Ha! I've got your document. Look at that. Wait, open that, thank you. God, is that not a thing of beauty? There's my serialized Poco in RavenDB. No mapping, no fuss. I just said, just store this thing. Just go on, get in there. Lovely. Let's close that again. Thank you, eSharper. So, yes. No. So is the internal ID always an integer? No. In fact, it's not an integer ever, unless you make it an integer. By default, it's a string. There you go. You can set this to whatever makes sense to you. If you've got some kind of natural key, you can just put it there. RavenDB won't overwrite what you give it. Yes. RavenDB is quite conventional at times. Obviously, you can override these. There's some settings somewhere. Just override the conventions. Get on with it. So it finds ID automatically and goes, hey, that's an ID. I'll assign something to that, and it makes sense. You'll notice, I'll just quickly go for the next demo, and we'll look at that. I'm going to create a user here. Oh, that shouldn't be there. What's going on here? I don't think eSharper will like. Oh, so it's indented. That's all right. Okay. Whew. So, here is to-do list, some deadline of some sort with a name, and a collection of items. It's beautiful. I know, I'm in love. I'm in love. I'm going to store that and save changes. What does this look like? If it works. It does. Wonderful. Look at this. I have a to-do list. Serialize the whole thing to a big blob. That's quite nice. But there's no relationships, as mentioned before. I can create a user here. And when it comes to storing a to-do list against that user, it's a manual process of just setting the user ID on that object. It's your responsibility, you do that. This means there's no relationship when I store this. Let's go look at that again. There you go. There's my user ID. You notice there it's actually got the type in it in the user ID too, as well as the type actually over here. You'll also notice the ID's jumped to 1025. Don't like it? Do it yourself. This is how it does unique IDs on the client. It's called high-low. I won't go into it. You can Google that. And Hibernate uses it too. If you used an Hibernate high-low, anybody? A few people, okay. It's quite nice because it means no chatting. Again, as developers, we don't like talking. Not as servers, not to each other. Okay, so I put data in. No, it's relatively simple. How do I get it out again? Well, it looks like this. I just pass in an ID and grab it out again. If they serialize whatever's there and give it to you. It doesn't really care about types, but there's some metadata in there, and it will throw an exception if you try and load something that isn't actually the type you're looking for, which is nice. If I run this, you'll see. There we go. There's my user. So round-tripping data is very simple, which is nice. Okay, so we've got data in, data out. How do I modify it? And this is where it starts, well, staying simple and easy. So OPM is going to create a user and store the ID. It's not really important. I think what I'll do, just debug this very quickly. Let's see what we got going. So my ID is users 3073. I'm a human being, not a number. My name is Ashton. I like being Ashton, that's who I am. But for some reason, it's the weekend and I decided my name's now Doris. So I change that property like that. And I hit Save Changes. That's now flushed. Let's go back and do this again. I love that. Let's hover. There we go. My name's now Doris. It's not. Don't call me Doris. So yeah, if I now load this out, I'm called Doris. How is them apples? As mentioned before, RavenDB is transactional. If you bulk send some stuff, that will be an atomic operation. So let's do that. Step through this, see what's going on. I stored a user and a to-do list just before. I'm going to load them out. So here, I've got a user. There you are. I'm called Rob again. And I've got a to-do list with some data. Nice big structure like that. Information on it, not very exciting. I decide once again that I'm called Doris. Maybe it's the weekend. Going to a party. And I decide that because I've changed my name to Doris, I've now got something else to do. Like brush my hair. So I'll add that. Nothing's happened yet. Still just in memory. If I ask for those items again, I'll get those items which will be modified, but they're not stored yet. I'll call Save Changes. That's all been flushed now in one operation. Either fails or it doesn't. If I go and look, a lovely server, it's getting full of data now. It's beginning to look much nicer. Look at this, it's gorgeous. Silverlight, it's the future web development. Unfortunately, I've lost Doris. I'm assuming he's on the height. There he is. It's called Doris. Beautiful. And he's got a to-do list, which is, I don't know, here maybe. Yep, that'll be the one. I got some items on it. So that's, oh, gorgeous. Just quickly run that. So yes, when I load that user out in the list, it's been modified quite happily, which is nice. So, querying. Ooh. Got indexes and documents and things happening everywhere, and that's really complicated and involves lots of setup. I wouldn't do that to you. I'm going to store a big pile of data. Looks like this. My test ain't going to pass because I've got data in RavenDB already and I can't bother deleting it. But let's look at it anyway. How do I query it? Link. But what am I missing here? What am I doing that I said I didn't do? I'm querying my documents. I'm not querying an index. Would you look at that? So get me all to-do lists for this user. Sir, yes sir, have some data. What's happened here? I just created a document, not an index. Why did that work? Well, it worked because RavenDB looked at your query and it said, you're querying a to-do list by the user ID. So let me sort that out for you. Ooh, not that one. I'll create the index for you. Don't worry about that. Just use it. Just use it. So if you don't specify an index, RavenDB will look at your query, work out what you want to achieve, and just sort that out for you. So it works for collections as well. So here, I'm saying, get me all the to-do lists where any of the items have a category of Raven. I assume we can all understand the link query, yeah? Yeah? I did a talk when no one knew link at all, and this was a very, very difficult talk to give. There we go. So list of all my to-do lists where there's an item of category Raven. Brilliant. Let's go and look at that. I create the index, do lists by items category, all human readable, which is nice, I can find it easily. Looks like that. And that's it really, it's not very exciting. However, if I want to create an index of my own, I can in my code. I simply inherit from my abstract index creation task and specify what the map looks like. Then on startup of the application, or when sorting things out, I call create indexes and give it the assembly and say just whatever indexes you got here, please create them. So go back here again, we'll see that my index to-do lists by user exists over here, to-do list by user, which is nice. And to use that, it's just the same. Except I now specify which index I want to use. Please use this index to query these documents. It's like before, you don't query documents, you query indexes, whether implicitly or explicitly. I do believe, actually, probably not this build, but probably in an unstable version, that RavenDB will actually, if you create indexes, it'll actually work out which one to use rather than creating one. Query optimization going on there. Don't know how stable that is yet. But hey, new features. So yes, this will work. It'll probably work quite badly, because of course I've just been storing lots of data in RavenDB. Because my tests aren't isolated. Bad job. So yes, I've now got 13, which is quite unlucky. Oh. So I went to Kevin Henning's talk and I realized that there's nothing in that. So, my tests aren't isolated. Let me fix that. Oops. Actually, probably want to do that way around. No, I want... Oh, dearie me. That was actually right to begin with. So, sorry, it was a very late night last night. The cool thing about this is now I can ask document database what's going on. Because it's in memory. Which means when I'm writing queries, because you know this whole background indexing thing, I probably should have mentioned that, it's an important point. Eventually consistent. Yes. Data over here might not be over here yet. If you have an SSD, it probably is. If you haven't got an SSD, might not be just yet. Which means when writing tests, it's quite hard to be deterministic. So it's generally, whenever writing a test, you end up with something that looks like this. Wait for the indexing to happen. And this suffices quite nicely. So not only am I running it in memory, I can now query it and say, what indexes are going on here? What am I doing? So there you go. I've now converted my tests to actually use the in-memory version, and will not look at that Silverlight application again, unless you ask me to. Why is this important? Because now we're going to do some actual querying. I'm going to blow your mind with some MapReduce. So, as mentioned on Wednesday, I like dashboards. I want a list of the top categories across all my documents, top 5. So I specify the output shape of that, and I say, I want a category and the number of times it happens. And I want to create an index for this. I'm creating an index from to-do list and creating this output shape. Feast your eyes upon my MapReduce. I'm going to go through every single document, every single category, and dump them out in a big list. Don't know why I've called it a tag. It's a bit silly. Oh well. And then I'm going to group by. Stick that over there. Really nice and simple. If I'm really lucky, my test will pass. So, I'm going to store a big pile of items. I'm going to query. The query looks very simple. There's nothing to it. Because I'm querying something that's already been done. I just simply say, hey, query my output shape, because that's what I want, and use this index. And this is pre-calculated, which means it's fast. My laptop, on the other hand, is not fast. So, wait for this. Thank you. Okay. What do you look at that? Category 3 happened twice. Category 2 happened 3 times. And category 1 happened 5 times. That's nice. I can obviously change that, because by default it's not ordered. There we go. Although actually I haven't specified a sort order for it, so that might not actually work. Let's pretend it works. And then fix it. If I have time to fix it, which I probably do. Okay, there we go. Ah, there you go. We're now sorted. Great. So what happens here is that I'm querying a pre-calculated index, but I can still query it however I want to. I can still manipulate the output shape of that if I want to. For example, oops. I'll claim that's because I'm doing F# or something. I don't know. I'm not cool enough to use F#. But I am cool enough to have a very slow laptop. There we go. So I can still do querying on that. This is full text querying, of course. So I can say, hey, find me all the popular tags across my site which start with the letter B. It'll do that for you. It's not just a toy, actually quite useful. And that is MapReduce. Useful thing. As I said, that's happening in the background. That is a predetermined result set. The operation of actually doing that is really fast. Don't cache it. If you need to cache it, you're probably doing something wrong, or you have a lot of users, in which case, congratulations. Most of you won't. Okay. Let's do something a little bit funky. I've written some more SQL. Please don't judge my SQL. As a developer, I am bad at writing SQL. I'm not saying all developers are bad at writing SQL, I'm just saying a lot of us are. And that's the problem, because we write things like this, and they go unnoticed. You don't see what's wrong with this, don't worry about it, neither did I. I actually really, I didn't. So I just wrote this, and some DBA in the audience went, ah, like that. What I want to do is I want to query my items. I want to pull out, what do I want to do here? I'll work it out. I can't remember. I want the user ID of the person who owns the task list. I want the name of the to-do list. And I want the number of items in the to-do list where is a certain user. So I want to say, get me all the to-do lists by the user, show me the information about those to-do lists, and also show me how many items are in those. So for example, on my home page, I want to list my to-do lists, show how many items are in them, pending or whatever, and I want to show only the to-do lists from me. It's my home page. I don't want SQL like that in my application, thank you very much. So what I do is I specify my output shape. Say, hey, I want the user ID, the name, the task count, and the display name of the user. Now what's going on here? What's wrong with this? I've got a document database with all my information in one document, except where I don't. I'm having to do a join across documents. Now, one of the things people chant on about is document databases, they're scalable. You don't do joins, just do normalized stuff. It turns out, actually, that most people still don't want to do that because it's a pain. Can be a pain. Turns out also that despite the fact it might limit your scalability, you can still do something here to pull back data. So, here's my index. Whoa. What's this third thing? We haven't used this yet. It is a third stage to our pipeline. In this case, it's our second, but it's the third. Just not showing the reduce. There isn't one. What I'm going to do is I'm actually just going to query the documents and select the user ID. That's what I'm querying by. I'm querying by user ID, so I need that in my index. So go through all the to-do lists and store the user ID over here. I'm then going to query that and get back a list of to-do lists for that user ID. And then going to limit the number coming back and maybe put some information in here too, like how many items are pending, and only put items in here that actually have to-do lists still, order by date, things like that. Whatever. Once RavenDB has done that, on the server, please transform the result set. And given a database and the results of my query, load some more information. So for example here, from all my results, load a user from the database by the user ID, and give me the user ID, the name of the list, how many items there are, just look at the count, look at the length of the array, because I've got that in memory, just use it. No aggregation required. And also give me the display name of the user. Now this is not a join, because when you do joins in a database, you're able to query on the join tables. You can't query on the join data here. You can still only query from a single document. So applause threw me off. I'm quite jealous. So please give me all the to-do lists and all the information from those and load these things up. Because I can't query on it, in fact, I can't query on it because I only do the transform after I've done everything else. Which means at this point, I probably only have 10, 15 items. And I'm going to, on the server, before I send anything over the wire, go and get that data. Probably from a cache in memory. 01. So it's not far, it's not difficult. The alternative to this, of course, would be going and fetching each item on the client, which is very similar to, except that would be the whole n+1 problem, where I've got lots of calls across the wire just to get data. Don't want to do that. So what does this look like when I actually do it? The actual query itself, pretty simple. Please query my to-do lists, use this index, and flatten it to a different kind of projection. Yes? So let's be patient and run this. And there we go. Create my to-do lists using this index and flatten it into that shape. There we go. There is the name of my list, how many items it has, and the name of, and my name in case I forgot it. Thankfully, it's not Doris. And there you have it. So there's a few things there, just so we're clear on this. I'm able to do effectively not joins across documents. They're called live projections. At least that's what we call them. We're able to do transactions. Those transactions, by the way, they honor the DTC. You can have multiple RavenDB instances and make changes to all of them and have them in production too. RavenDB gives you the ability to do this because most people's needs are not to scale. They're simply, I really hate faffing with a database. I'm going to store some data over here and do some stuff, but I don't want to lose any of the nice things from my database. Oh, definitely not. When you need to scale, you don't use transactions and you don't do joins because you're probably sharding. And if you're sharding, you don't know if a shard's up or not. You don't know if the data's there yet or not. You don't know where it is. You ought to be partitioning your data very sensibly. But most people's needs are not to scale. So RavenDB has a very different focus to the other document databases. Actually, Couch these days has a very different focus again. It's just to be a very small, portable database, which is quite nice. Mongo's neat. Well, let's not talk about Mongo. I don't like Mongo. Much. I'll give it some grace. Talk about it later if you want to, not here. I don't want to start going on a big rant. So yes, stuff. What I just said. Should probably put the slide before, shouldn't I? Anyway, Lucene has full text search. So okay, I'm not really using it in those demos. But I can do, hey, that's got a paragraph of data. Please search for any blog entry which mentions RavenDB. Just give it to me. Really fast. So I've got the whole did you mean thing. I misspelt something, but did you mean this instead? So I typed in MongoDB and it goes, did you mean Raven? It has faceting support. Who here knows what a facet is? Okay. Who here has used Amazon.com or variant of? Good. You know when you're doing a search on Amazon and you do a search and then down the left-hand side there's things you can click on to narrow down your search. Yes? Those are facets. You're drilling down on facets of the data. Lucene has those, therefore RavenDB has those too. Got all these things for free. It's also got geospatial queries because for some reason everyone always seems to want them. I've never had a need personally. Apparently everyone else does. RavenDB itself has ad hoc queries. I can just query stuff and get data back. Which is nice. Got live transaction support, live projections, full text search baked in as mentioned just now. Set-based operations too, I didn't cover those. Please update all my users and change their preferences from MongoDB to RavenDB. Just do that for me. Please delete all the users who like MongoDB. It's really easy. It's also very pluggable. The whole thing's written in C#. Who here knows C#? Who here knows Erlang? Good luck with that. Couch is written in Erlang, in case you're wondering. Because it's written in C#, well, not because, but we all know C#, it's written in C#, the plugin model uses C#, you can write C# to plug into it. You can probably use VB as well if you so choose. I won't judge you. Because it's pluggable, there's some plugins provided for already. They're called bundles. I want the data replication bundle. I want the index replication bundle. So I want to replicate documents across shards. I want to replicate the indexes across these different stores. I want documents to expire after a certain time. I just want them to go away. It's got versioning. Real versioning too. CouchDB has versioning, except for if you tie the database, they go away. They're not actually versioned. If you change a document, please store the old version somewhere so I can get at it and store the last 50 versions of the document. it can just do that with a bundle. The plugin model allows this. There's also a security bundle. Please put some users in and determine permissions for those users. So when I query documents, I can lock down access to those documents. Which is quite nice. It's also got relational database replication. I'll talk about that. I really like that feature. Answer the question on Wednesday. And indexes. If you can't express in your index in LINQ, write the index in C# and load it into RavenDB as a plugin. And then you've got for loops and everything else you might want to do in a crazy thing. You can do whatever it is you want to do that you can't do with LINQ. So, before I talk about the next thing, RavenDB, or document databases in general, they make excellent primary data stores for applications. Our application has needs, and document databases sort those needs out for the application. However, what about reporting? If you're running an application for business, they're probably going to want reporting at some point. They always want reporting. And they probably want to use something off the shelf like Crystal or BERT or something like that. Obviously, you can't point out that Raven has no idea what Raven is. And Raven's not built to do that anyway. Probably wouldn't want to. So, let's look at relational database integration very quickly and just show how it works. Here are two indexes, custom data, where I select the list ID, the title, and the user ID from some lists. I also select all the items from those against all the list ID, the category, and the title. What does this look like in the indexes that are created? Well, the first one looks like that. List ID, title, user ID. Second one looks like this. List ID, category, title. Hang on a second. This looks very familiar. By flattening our documents into a different store and assigning columns to those, it actually looks like I could put this in a relational model. And that's exactly what you do. So you can actually tell RavenDB, hey, these indexes over here, could you please replicate these into a relational database that has this setup? Then you can go mad and put foreign keys on it and indexes and whatever and do crazy queries of joins and counts and XML parsing or whatever it is you do in a relational database these days. Fantastic. Then I can plug Crystal at that and get reports out of my system if I really want to. That's nice. So, I'll end by saying RavenDB is pretty cool. If you're not using it already or trying it already, you probably should look at it. Because we're seeing a lot more of it in the future. It's becoming quite commercial. People are actually using it. It's very exciting for me. Is it the answer? Of course it isn't. Who asked that question anyway? No one here, actually, because again, you're very intelligent. Are you working in an online transactional environment? Probably. You're probably working on something where you have entities, you perform modifications, interaction, and you save those entities, and later on, query them out again. The thing about that is it's very low write and high read. RavenDB is great for that. If you have complex reporting needs, okay, you can do that with a combination of Raven and relational databases. If you are a pure data app, then you're probably not using RavenDB, you're probably doing star schemas and crazy things in relational databases. That's fine. It's not a silver bullet. It's good for a certain class of problems, and very good at them. So if you're not doing something that fits it, don't try and use it. Don't try and shoehorn it in there. You know, give it a little go and go, no, it doesn't fit. I'm not going to kind of doing that. Very quick note. I made a distinction very early on about the separation between documents and indexes. That's a read store and a write store. And if I build my application on top of that concept, and my reads are very thin, I showed on Wednesday the idea that actually if you're using JSON on the front end and JavaScript on the front end, that just getting data from RavenDB makes perfect sense via one little query. Just go and get that for me from the views, from the indexes. But your documents are your write store. Take all the validation and things in front of that and do what you want. CQRS. Anyway, we have time, I think, for some questions. Not very much time. And I've realized that you guys don't like asking questions publicly anyway, so I'll be out there writing code all day, and you can come and say hello to me, and I'll answer questions there as well. But try here anyway, if you've got any. Anybody want to ask anything? Yes? Mm-hmm. Of course. Okay, yes. It's a good question. So the question is, what happens when my schema changes? We might not actually have a schema, but we do have an implicit one. We have documents and they have a shape. What happens when the shape changes? What happens on my POCO when I suddenly add a new property? Or I remove a property? If I remove a property, there's actually no harm in leaving it in there. It'll end up disappearing over time as you load it out and save it in again. When I add a new property, that's an interesting one. It's an interesting one because the other documents don't have that yet. Chances are you don't want to do check for null everywhere because it's a pain. It's okay because Raven has set-based operations. So you will end up writing series of migration scripts. You can't get away from it, ever. There's no getting away from that problem. RavenDB makes it easy by not imposing a schema. You can do what you want. But you probably will end up with migration scripts saying, hey, I've changed this, I've changed this. You'll have systems in place where you'd never rename a property. Maybe you version your documents. Maybe you do these things. It's up to you. RavenDB isn't going to impose a rule on you for that. But yeah, it's sensible to do migration over time and not leave nulls lying around everywhere, unless nulls actually make sense in your model. Another question over there. Yes? Examples, there's a Stack Overflow data import, and some indexes written against that. That's quite a large data set. If you look at IND's blog, it's got search in it. Or will do, if it doesn't already. And his blog's open source on GitHub. It's called Raccoon Blog. Very nice example of how to use RavenDB. Very nice example of how to do something very simply as well. And that's what RavenDB has a power for. It's doing things simply. So yes, there are data sets out there and queries against data sets. If you look at my blog, I've actually got some examples of how to do searching on things. It's very powerful. But I say very simple as well. Any other questions? Yes? Very good question. I probably should have mentioned that, shouldn't I? It's hard to cover everything. There's a lot. The question is, those temporary indexes. If we go back to, actually, I promise not to show this Silverlight again. I probably can't. I've probably closed it. It was created with a name of temp / to-do lists by user ID. Temp. What's that actually mean? What it means is that when the database restarts, it will vanish. Over time, if not used, it will vanish. However, if it's used in a certain frequency, number of times in a certain time, magic numbers, no idea what they are, top of my head, then they will stay around. They'll be promoted. And they get promoted into automatic indexes. And that temp changes into an auto. So you still know it's created by RavenDB. You still know it's automatic. But that auto, that change to auto means it's now going to stay around forever, unless you delete it, which you can. It'll count working. It'll just get created again later on if you need it. So I hope that answers your question. Of course you do. I do. When I first added that feature, I didn't. I went, oh, no one's going to use that. Turns out, actually, everybody wants to. And it works really well. The only downside to it is, of course, when you create it, there will be initial population time. It has to go, well, I've got empty index, there's no point in returning anything now. So it'll wait around for that index to get populated, then return data. So first time you query it, it might be slow. But if you've got an application that you deploy, like I've deployed it, probably hasn't got much data anyway. And as you use it, the indexes get created, and as you get more data, it's all there. So there's no problem there. Not a big one. I sometimes prefer to use explicit indexes because, of course, then I get live projections, and I get to do group bys, and everything's nice and explicit. And Raven will choose to actually use them if they're there, which is useful. Anything else? Yes? Sorry? When you do back, no, Xcopy. Or user application. There's actually a tool called Smuggler, again, in the RavenDB package. And Smuggler is for taking data out and putting data in. Sneaks it in there. So you use that, basically. And there's a command line tool so you can automate it too. But backup is basically Xcopy. It's a bunch of files on the hard drive. No real special considerations. Of course, they are locked, so writing over them would be very difficult. But yes, there's a tool for it anyway. Right. Unless there are any more questions, I think we're done. I say I'll be outside in the lobby writing code all day, and you can come and say hello, and I will answer all your crazy questions. Thank you.